On November 2nd, 2025, an object appeared in space that should not exist, not because it's alien, not because it's impossible, but because no professional observatory on Earth detected it first. An amateur astronomer in Crimea, using a homemade telescope in his backyard, discovered a comet positioned directly in the corridor between Earth and the most scrutinized object in modern astronomy, the interstellar visitor 3I Atlas. And here's what makes this discovery more than just another rock in space. The man who found it is Gennady Borisov, the same Gennady Borisov who, 6 years ago, became the first amateur astronomer in history to discover an interstellar object. 2I/Borisov in 2019. How is that even possible? Think about what that means. Every major observatory on this planet has been pointed at 3I Atlas since its discovery. Professional astronomers with billion-dollar instruments, space agencies with satellites. And yet, on November 2nd, this new object, C/2025 V1 Borisov, materialized in our telescopes, sitting at magnitude 12 brightness, visible to any decent amateur telescope. Somehow, the most sophisticated surveillance network humanity has ever deployed missed it. Until one man, working alone at his Margot Observatory in Nochny, Crimea, caught what everyone else overlooked. But here's where this story shifts from curious coincidence to something demanding investigation. C/2025 V1 Borisov is behaving exactly how 3I Atlas should be behaving but isn't. It has a visible coma, it has a tail, it's brightening on schedule as it approaches perihelion on November 16th. Every prediction about comet behavior, V1 Borisov confirms them, which means our models work, our instruments work, our understanding of cometary physics works. So why doesn't 3I Atlas follow the same rules? Over the next several minutes, we're going to examine something most coverage of 3I Atlas has completely missed, that the appearance of C/2025 V1. Borisov isn't just another space rock story. It's the control experiment we didn't know we needed. Proof that when something genuinely anomalous appears in our solar system, we can recognize it because we know what normal looks like, and 3I Atlas is not normal. Before we go further, hit that like button if you've been following the 3I Atlas story. And drop a comment telling me where you're watching from and whether you've heard about Gennady Borisov's connection to this before today. Because what you're about to hear changes the entire conversation around what's happening between Earth and 3I Atlas right now. Let me take you back to August 30th, 2019. It's early morning at the Margot Observatory in Nochny, Crimea. Gennady Borisov is conducting his routine sky survey with his homemade 65cm telescope, a custom design he built himself called the Xenon telescope. He's been doing this for years, night after night, scanning regions of the sky that professional automated surveys often skip, and on this particular morning, he notices something in the constellation of Cassiopeia that shouldn't be there. A fuzzy object, moving, fast. Too fast to be an asteroid from the main belt. He takes another image an hour later. It's moved. He measures the trajectory. The numbers don't make sense. This object isn't orbiting the sun in the way solar system objects do. It's coming from somewhere else entirely. Within days, his discovery is confirmed by observatories around the world. 2I/Borisov becomes only the second interstellar object ever detected passing through our solar system, after Oumuamua in 2017. But here's what makes this historic. Gennady Borisov isn't affiliated with any major observatory. He isn't running automated sky surveys funded by millions in research grants. He's a telescope engineer working at the Crimean Astrophysical Observatory during the day and running his own amateur observation program at night. And he just became the first amateur astronomer in human history to discover an object from another star system. The Guinness World Records later recognizes this achievement officially. One man, one homemade telescope, one object from beyond our solar system. Now think about what that accomplishment represents. Professional astronomy has access to networks like Pan-STARRS, the Catalina Sky Survey, and the Zwicky Transient Facility. Automated systems that scan millions of square degrees of sky every night, cataloguing every moving object they can detect. These systems are designed specifically to catch objects like comets and asteroids before amateur astronomers even have a chance. And yet, Gennady Borisov, working alone with equipment he built in his workshop, found something those billion-dollar systems missed. Not just any object, but the most significant comet discovery of the 21st century. That should tell you something about how exceptional his observational skills are. That should also tell you something about the gaps in our professional surveillance network. Fast forward to November 2nd, 2025, 6 years later. Same astronomer, same observatory, same telescope, different object. Borisov detects another comet in the constellation Virgo, glowing at magnitude 12.0 with a visible coma measuring approximately 25 arcseconds in diameter. He reports it immediately to the Minor Planet Center. Confirmation comes quickly from other observatories. This time, however, the object isn't interstellar. Orbital calculations reveal it's a long-period comet from the Oort cloud, that vast reservoir of icy bodies surrounding our solar system at distances reaching nearly a light-year from the Sun. Its official designation, C/2025 V1 Borisov, named after its discoverer, as is standard practice in comet nomenclature. But here's what nobody in the mainstream astronomy community is talking about publicly. What are the odds? What are the actual statistical odds that the same amateur astronomer who discovered 2I/Borisov in 2019, an interstellar visitor, would also discover a completely separate comet, C/2025 V1, in 2025, during the exact window when humanity is tracking another interstellar visitor, 3I Atlas, not just in the same year, not just in the same season, but in the same region of sky, positioned along the corridor between Earth and 3I Atlas's trajectory. Let me put this in perspective. Since the beginning of systematic comet discovery in the 19th century, thousands of comets have been discovered. Of those thousands, only a handful have been found by the same individual discovering multiple, historically significant objects. And among amateur astronomers, the probability of discovering even one object of interstellar origin is so infinitesimally small that before Borisov, it had never happened in all of human history. Now consider that he's discovered two objects, one definitively interstellar, one from the Oort cloud, both during periods when interstellar visitors are making close approaches to Earth. Either Gennady Borisov is the luckiest astronomer alive, operating during a cosmic coincidence of unimaginable proportions, or there's something about his methodology, his observation patterns, or his chosen survey fields that's consistently placing him in the right position to catch what everyone else is missing. I'm not suggesting anything conspiratorial here. I'm stating a fact that demands acknowledgement. The man has a track record. When Borisov reports a discovery, it matters. When he points his telescope at a region of sky and says, "There's something here," the global astronomy community stops and pays attention, because twice now he's been right when everyone else was blind. And this time, what he's found isn't just another comet for the catalogue. This time, what he's found is the Rosetta Stone we needed to understand what's actually strange about 3I Atlas. Because here's what makes C/2025 V1 Borisov so critical to this investigation. It's normal, completely, utterly, predictably normal. And in the context of 3I Atlas's behaviour, normal is exactly what we needed to see to prove that our instruments aren't broken, our models aren't broken either, aren't wrong, and our understanding of cometary physics isn't flawed. When a comet from the Oort cloud approaches the inner solar system, here's what should happen. As it gets closer to the Sun, solar radiation heats the icy nucleus. Volatile compounds, water ice, carbon dioxide, methane, begin sublimating, turning directly from solid to gas. This outgassing forms a glowing coma around the nucleus, and, under the pressure of solar wind and radiation, gets pushed away from the Sun, creating a visible tail. The comet brightens as it approaches Perihelion, its closest point to the Sun, because more surface area is exposed to solar heating, increasing the sublimation rate. This is Cometary Physics 101. This is what every long-period comet does. This is what C/2025 V1 Borisov is doing right now in real time, exactly as predicted. Which brings us to the question nobody wants to ask out loud. If V1 Borisov is behaving normally, following every rule in the book, confirming our models with textbook precision, then why isn't 3I Atlas? Both objects are approaching the Sun. Both are supposedly comets. Both should be outgassing. Both should have tails. Both should follow predictable brightness curves. But only one does. Only V1 Borisov is playing by the rules. And the object that's breaking every rule, the object that has no tail, no predictable brightness curve, no conventional cometary behaviour, is the one that's interstellar. The one that came from outside our solar system. The one that every major observatory on Earth is watching. And now, thanks to Gennady Borisov's discovery, we have a direct comparison. We have the control experiment. So when I tell you that the appearance of C/2025 V1 Borisov changes everything about the 3I Atlas investigation, I'm not exaggerating for effect. I'm telling you that for the first time since 3I Atlas appeared in our skies, we have a baseline. We have proof that our instruments work, that our models are accurate, and that when something genuinely anomalous shows up, we can identify it because we know what normal looks like. And that brings us to what Borisov actually found, what this object is doing right now, and why its behavior is the key to understanding what 3I Atlas is not. Right now, as I'm recording this, C/2025, V1 Borisov is visible in the constellation Virgo, shining at magnitude 13.8. That's dim compared to what it was at discovery, magnitude 12.0, but that fading as expected. It reached its perihelion, its closest approach to the Sun, on November 16, 2025, at a distance of 0.46 astronomical units. That's 46% of the distance between Earth and the Sun. In kilometers, that's approximately 69 million kilometers from our star. It's moving away from the Sun now, heading back out into the depths of space, and as it does, the solar heating that caused its outgassing is decreasing. Less heating means less sublimation. Less sublimation means less brightness. The coma, the glowing cloud of gas and dust surrounding the nucleus, is still visible, currently measuring about 2.3 arc-minutes in diameter, roughly the size of a small lunar crater as seen from Earth. It also has a small but distinct tail, visible in long-exposure images from amateur telescopes worldwide. Everything about this object's appearance screams comet. But let's dig into the orbital mechanics, because this is where things get interesting. C/2025 V1 Borisov has an orbital eccentricity of 1.0095827.3. Now, if you're not familiar with orbital mechanics, let me explain what that number means. In orbital dynamics, eccentricity measures how elliptical or circular an orbit is. A perfect circle has an eccentricity of 0. The more elliptical the orbit, the closer the eccentricity gets to 1. Anything with an eccentricity greater than 1 is on a hyperbolic trajectory, meaning it's not gravitationally bound to the Sun. It's just passing through, and it will leave the solar system eventually. V1 Borisov's eccentricity is slightly above 1, which makes it hyperbolic. But here's the critical detail most people misunderstand. A hyperbolic orbit doesn't automatically mean interstellar origin. Let me explain why. Comets from the Oort cloud start their journey gravitationally bound to the Sun, with orbital eccentricities very close to but below 1.0. They're on extremely elongated elliptical orbits that take millions of years to complete. But when a comet from the Oort cloud falls inward toward the inner solar system, it picks up speed. A lot of speed. By the time it reaches perihelion, it's moving fast enough that gravitational interactions with the planets, especially Jupiter, can give it a velocity boost, kicking its eccentricity just above 1.0. This doesn't change the fact that it originated within our solar system. It just means it's now on an escape trajectory. After this single pass through the inner solar system, it will leave and never return. That's exactly what's happening with C/2025 V1 Borisov. It's an Oort cloud comet on a hyperbolic trajectory due to gravitational perturbations, not an interstellar visitor. How do we know that for certain? Because of its velocity and approach vector. True interstellar objects like 2I/Borisov and 3I Atlas approach the solar system with excess hyperbolic velocity. They're moving faster than any object gravitationally bound to the Sun should be moving at that distance. Their trajectories don't intersect with any known orbit of solar system objects. They're coming from specific points in the sky that correspond to directions in interstellar space. C/2025 V1 Borisov, on the other hand, has an orbital inclination and trajectory consistent with Oort cloud origins. Its velocity matches what we'd expect from an object falling inward from the outer reaches of the Sun's gravitational influence. It's not interstellar. It's ours. It's just leaving after this visit. And that distinction matters because it tells us what to expect from its behavior. Oort cloud comets have a specific composition. They're pristine leftovers from the solar system's formation 4.6 billion years ago, composed primarily of water ice, carbon dioxide ice, methane, ammonia, and a mix of rocky and organic material. When these ices sublimate under solar heating, they produce the characteristic coma and tail that define cometary activity, and that's precisely what C/2025 V1 Borisov is showing us. The coma became visible when it was still beyond 2 astronomical units from the Sun, meaning its surface ices started sublimating early, a sign of volatileic composition. As it approached perihelion at 0.46 astronomical units, the coma expanded, the tail developed, and the brightness increased right on schedule. This is what every long-period comet does when it visits the inner solar system. Let me take you through the brightness curve specifically, because this is where the contrast with 3I Atlas becomes stark. A discovery on November 2nd, V1 Borisov was magnitude 12.0. By November 11th, when it made its closest approach to Earth at 0.68 AU, that's about 103 million kilometers, it had brightened slightly to around magnitude 11.5. Then, as it approached perihelion on November 16th, reaching 0.46 astronomical units from the Sun, it peaked at approximately magnitude 10.8. That's a predictable, steady brightening consistent with increased solar heating as the comet moved closer to the Sun. Now, as it moves away from perihelion, it's fading again, currently sitting at magnitude 13.8. If you plot that brightness curve on a graph, it follows a smooth, predictable parabola. There are no sudden jumps, no unexpected fluctuations, no anomalous brightening episodes. It's doing exactly what the physics predicts it should do. Contrast that with 3I Atlas. Here's an object that reached perihelion on October 29, 2025, at a much greater distance, 1.356 astronomical units from the Sun. That's nearly 3 times farther from the Sun than V1 Borisov's perihelion. At that distance, solar heating is significantly weaker. The intensity of solar radiation decreases with the square of the distance, meaning at 1.356 astronomical units, 3I Atlas is receiving only about 54% of the solar energy that Earth receives, and far less than what V1 Borisov experienced at 0.46 astronomical units. Under those conditions, you'd expect minimal cometary activity from 3I Atlas, maybe a faint coma if it's particularly volatile rich, but a prominent visible tail, absolutely not. Yet despite being farther from the Sun and receiving less solar heating, 3I Atlas has exhibited brightness fluctuations that don't match any cometary model. And here's the kicker, it has no visible tail, none. 0 detectable tail formation despite undergoing perihelion passage. Now you might be thinking, maybe 3I Atlas just has a different composition. Maybe it's depleted in volatiles. Fine, that's a reasonable hypothesis. But here's the problem with that explanation. If 3I Atlas were a comet depleted in volatile ices, it shouldn't be brightening at all. A comet without active sublimation is just a dark, inert rock reflecting sunlight. Its brightness would follow a simple inverse square law based on distance from the Sun and distance from Earth, with no deviations. But 3I Atlas has shown unexpected brightening at times when standard cometary physics predicts it should be dimming or remaining stable. That's not consistent with a depleted comet. That's consistent with something else driving changes in reflectivity or surface activity. And this is why C/2025 V1 Borisov is so valuable. It's the proof of concept. It's the demonstration that when a comet behaves normally, we can predict its behavior with extraordinary precision. We can calculate when it will brighten, how bright it will get, when the coma will form, and when the tail will appear. We've been doing this for centuries. The models work. V1. Borisov confirms they work. So when 3I Atlas doesn't follow those models, we can't blame the models. We can't say, well, comets are unpredictable, because they're not. They're highly predictable when they follow the rules, which means if 3I Atlas isn't following the rules, it's because something about 3I Atlas is fundamentally different. Let me give you one more comparison to drive this home. V1 Borisov has a visible coma, measuring 2.3 arc minutes in diameter right now, even though it's moving away from the Sun and fading. That coma is the result of ongoing sublimation, gas and dust particles escaping from the nucleus, forming a cloud that scatters sunlight. The coma's size and brightness are directly proportional to the rate of sublimation, which is directly proportional to the solar heating at the comet's distance. This is straightforward physics. Now, 3I Atlas at perihelion, closer to the Sun than it will ever be during this pass, should have exhibited a coma of comparable or greater size if it were a standard comet. But observations from multiple facilities reported either no detectable coma or an extremely faint asymmetric structure, inconsistent with typical outgassing patterns. That's not a minor discrepancy. That's a fundamental difference in behavior that demands explanation. So here's where we stand. C/2025 V1 Borisov is behaving exactly as a long-period Oort cloud comet should behave. Visible coma, visible tail, predictable brightness curve, composition consistent with volatile ices sublimating under solar heating. Every checkbox on the normal comet behavior list is checked, and this object is currently positioned in the sky between Earth and 3I Atlas's trajectory, providing us with a real-time side-by-side comparison of what normal looks like versus what 3I Atlas is showing us. And what that comparison reveals is that we're not dealing with two comets behaving slightly differently due to compositional variations. We're dealing with one object that confirms our understanding of cometary physics and another object that defies it. Now let's examine exactly how stark that contrast really is. I want you to imagine two objects, both discovered within months of each other, both in the same general region of the sky, both classified as comets, both approaching perihelion in late 2025. Now let's put them side by side and examine what happens when we compare every measurable parameter. Because when you do that, when you actually line up the data, the pattern that emerges isn't just interesting, it's diagnostic. It tells you that one of these objects is exactly what it's supposed to be, and the other is something we don't have a category for yet. Let's start with perihelion distance, C/2025 V1. Borisov reached perihelion on November 16, 2025, at 0.46 astronomical units from the Sun. That's 69 million kilometers. At that distance, solar radiation is intense, more than 4 times stronger than what Earth receives. That's enough energy to sublimate water ice, carbon dioxide ice, and other volatile compounds efficiently. The result? A visible coma, a visible tail, and significant brightening as the comet approached that point. Now, 3I Atlas reached perihelion on October 29, 2025, at 1.356 astronomical units from the Sun, approximately 203 million kilometers. That's nearly 3 times farther away than V1 Borisov's perihelion. At 1.356 astronomical units, solar heating is considerably weaker. The intensity is roughly 54% of what Earth receives, and about 1/5 of what V1 Borisov experienced at its closest point to the Sun. So here's the question. If V1 Borisov, at 0.46 AU with intense solar heating, develops a visible tail and prominent coma, what should we expect from 3I Atlas at 1.356 AU with much weaker heating? The answer is simple. Less activity. Maybe a faint coma if it's rich in volatiles. But a prominent bright tail? Number. Definitely not. The farther you are from the Sun, the less solar energy is available to drive sublimation. That's non-negotiable physics. And yet, here's what observers have reported. 3I Atlas, at its perihelion of 1.356 astronomical units, has shown no visible tail, none, 0 detectable coma formation in the conventional sense, and instead of fading predictably as it moved away from perihelion, it exhibited unexpected brightening events that don't correspond to any known cometary mechanism. Let me repeat that because it's critical. The object that's closer to the Sun is behaving like a comet. The object that's farther from the Sun, where cometary activity should be minimal or absent, is not behaving like a comet, and yet it's showing activity that shouldn't be happening at that distance. That's not a compositional variation. That's a complete inversion of expected behavior. Now let's talk about brightness curves, because this is where the comparison becomes undeniable. V1 Borisov's brightness followed a predictable pattern. Magnitude 12.0 at discovery on November 2nd, brightening to magnitude 10.8 near perihelion on November 16th, then fading back to magnitude 13.8 as it moved away from the Sun. That's a smooth parabolic curve. If you graph it, the data points line up beautifully with theoretical predictions based on inverse square law and sublimation physics. There are no outliers, no sudden jumps, no anomalies. It's textbook. 3I Atlas, on the other hand, has shown brightness variations that deviate from standard cometary models. In September 2025, as it was still approaching perihelion, observers noted unexpected brightening that wasn't accounted for by changing distance from the Sun or Earth. Then, after perihelion passage in late October, instead of fading steadily as it moved away from the Sun, the way V1 Borisov is fading right now, 3I Atlas exhibited additional brightening episodes. Some researchers have suggested this could be rotational variation, where different sides of the nucleus with varying albedo come into view. but rotational brightness changes are periodic and predictable once you measure the rotation period. The variations in 3I Atlas's brightness don't fit a clean rotational pattern. They're irregular. And here's the deeper problem. If this were rotational variation, we'd expect to see it in V1 Borisov too, since all comets rotate. But V1 Borisov shows no such irregularities. Its brightness curve is smooth. So why would 3I Atlas behave so differently? Then there's the tail issue, and this is where the contrast becomes impossible to ignore. V1 Borisov, even now at magnitude 13.8 and moving away from the Sun, still has a visible tail in long exposure images. It's not a massive dramatic tail like you'd see in a great comet, but it's there, a faint streak of dust and gas being pushed away from the coma by solar wind. That tail is the smoking gun of active sublimation. It's proof that volatile ices are escaping the nucleus, forming gas and dust particles, and being swept back by radiation pressure. Every comet with active sublimation produces a tail. It's unavoidable. The physics doesn't allow any other outcome. Solar wind and radiation pressure act on the outgassed material, and a tail forms, always. 3I Atlas at Perihelion, despite being closer to the Sun than it will ever be during this pass, has no visible tail. Observations from multiple observatories, including professional facilities and experienced amateur astronomers, have consistently reported the absence of a tail. Some have reported a very faint, diffuse, coma-like structure, but nothing resembling the classic cometary tail we see in V1 Borisov. Now, you could argue, maybe 3I Atlas is just less active. Maybe it's depleted in volatiles. But then you'd have to explain the brightness changes. A depleted comet is inert. It's just a rock reflecting sunlight. Its brightness would be predictable based purely on geometry. But 3I Atlas isn't behaving like an inert rock. It's showing changes that suggest something is happening on or near its surface. Activity without outgassing? That's not standard comet behavior. And then we come to the color changes, and this is where the strangeness reaches a new level. In July 2025, when 3I Atlas was first being intensively observed, some reports described its spectrum as showing a reddish coloration, consistent with organic rich material or dust particles scattering light. By September 2025, observers noted a shift toward greenish tones, which in cometary science usually indicates the presence of diatomic carbon or cyanogen gas in the coma. But here's the problem. If 3I Atlas has no significant coma, where is that green emission coming from? And by November 2025, after perihelion, some observers reported a bluish tint, which typically suggests ionized gas or different scattering properties. Now V1 Borisov, over the same time period it's been observed, has maintained a consistent appearance. Its colour profile matches typical cometary dust and gas emission spectra. No dramatic shifts, no unexplained changes. It looks like a comet from every angle. 3I Atlas looks like something cycling through different states. Let me pause here and address what you might be thinking. Couldn't these differences just be due to different compositions? Maybe 3I Atlas formed in a different part of another star system with a different chemical makeup. That's a fair question. And yes, interstellar comets could theoretically have different compositions than solar system comets. But here's the issue. Composition differences would affect the details of behavior, not the fundamental physics. A comet made primarily of carbon dioxide ice instead of water ice would still sublimate under solar heating. It would still produce a coma and tail. It would still follow predictable brightness curves based on sublimation rates. The specific gases emitted might be different. The timing of activity might shift, but the general pattern would remain the same. What we're seeing with 3I Atlas isn't a variation on the theme. It's a different theme entirely. And let's talk about non-gravitational acceleration, because this is the parameter that truly sets 3I Atlas apart. When a comet sublimates, the escaping gas exerts a tiny rocket-like thrust on the nucleus. This is called non-gravitational acceleration, and it's well documented in cometary science. The outgassing isn't perfectly symmetric, so the comet gets a little push in one direction. This causes the trajectory to deviate slightly from a purely gravitational orbit. The effect is small but measurable with precise astrometry. V1 Borisov, with its visible coma and tail, should exhibit detectable non-gravitational acceleration. And if we had long-term tracking data on it, we'd probably find evidence of that. 3I Atlas, despite having no visible tail and minimal coma, has shown detectable non-gravitational acceleration. Orbital refinements from multiple observations have revealed that its trajectory is deviating from a purely Keplerian orbit in a way that requires an additional force beyond gravity. If that force is outgassing, where's the tail? Where's the visible coma? If it's not outgassing what's pushing the object off its gravitational trajectory, this is the central paradox. von Borisov shows all the signs of outgassing: coma, tail, brightness curve, and presumably has the non-gravitational acceleration to match. 3I Atlas shows almost none of the signs of outgassing, yet it's experiencing measurable non-gravitational forces. Either there's a type of sublimation we don't understand that produces thrust without producing visible gas and dust, or the acceleration is coming from something else entirely. Now, I want to bring in one more piece of context that ties this comparison together. Dr. Avi Loeb, the Harvard astronomer and chair of the Galileo project, has pointed out that 3I Atlas's trajectory passed within approximately 9 degrees of the origin point of the famous WOW signal, the 1977 radio signal detected by SETI, that remains one of the most compelling unexplained signals in the search for extraterrestrial intelligence. That's not proof of anything, but it's a data point, a coincidence perhaps, but one that raises eyebrows when combined with everything else we're seeing. V1 Borisov, by contrast, has no such alignments. It's an Oort cloud comet on a trajectory consistent with gravitational dynamics. It has no mysterious correlations, no unexplained behaviors, no anomalies. It's exactly what it appears to be. So here we are. 2 objects, both labelled as comets, both observed during the same time frame, both approaching perihelion within weeks of each other, and yet one confirms every model we have, while the other breaks every rule. One behaves exactly as centuries of observational data predict, while the other behaves in ways we have no framework for. And the man who discovered the normal one, he's the same man who discovered 2I/Borisov, the first confirmed interstellar comet. He knows what interstellar visitors look like. He knows what normal comets look like. And when he points his telescope at the sky and finds C/2025 von Borisov sitting between us and 3I Atlas, what he's really giving us is a Rosetta Stone, a translation key, a way to understand that the strangeness of 3I Atlas isn't in our instruments, our models, or our understanding, it's in the object itself. Which brings us to the timing, the trajectory, and the questions nobody in positions of authority seems willing to answer publicly. Let's map the timeline, because when you lay out the dates in sequence, the convergence becomes impossible to dismiss as random chance. July 2025, 3I Atlas is discovered, an interstellar visitor confirmed to be on a hyperbolic trajectory, entering the inner solar system from interstellar space. August through September. Intense observation campaigns begin. Professional observatories, space agencies, and amateur astronomers around the world start tracking its approach. October 2093-0, 2025. 3I Atlas reaches perihelion at 1.356 astronomical units from the Sun. This is the closest it will ever get to our star. November 2nd, 2025. Just 3 days after 3I Atlas's perihelion, Gennady Borisov discovers C/2025 V1 Borisov in Virgo. November 11th, 2025. V1 Borisov makes its closest approach to Earth at 0.68 astronomical units. November 16th, 2025. V1 Borisov reaches perihelion at 0.46 astronomical units, and now, ahead of us, December 19th, 2025, just 41 days away, 3I Atlas will make its closest approach to Earth at 1.8 astronomical units, approximately 270 million kilometers away. Think about that sequence. Within a span of less than 3 months, we have the perihelion of an interstellar object, the discovery of a new Oort cloud comet by the world's only amateur astronomer to have previously discovered an interstellar object, and the closest approach of 3I Atlas to our planet, all happening in the same observational window. And here's what makes the geometry even more compelling. C/2025 V1 Borisov is positioned in the sky, along the corridor between Earth and 3I Atlas's trajectory. It's not directly in the line of sight. Space is 3-dimensional, and the objects are at different distances, but they're in the same general region as viewed from Earth. That means anyone observing 3I Atlas right now is also seeing V1 Borisov in the same field of view, depending on telescope magnification. It's a built-in comparison, a celestial control experiment happening in real time. Now December 19th is the date everyone should have circled on their calendar, because that's when 3i Atlas reaches its closest approach to Earth. At 1.8 astronomical units, it's still farther away than the Sun is from us, but it's closer than it's been since entering the inner solar system, and it's the point at which Earth-based observations will have the highest resolution and sensitivity. If 3i Atlas is going to reveal anything definitive about its nature, it will be during the weeks surrounding December 19th. That's the window when any tail development, any brightness changes, any spectroscopic signatures, or any trajectory deviations will be most clearly detectable. And here's the critical question. Will 3i Atlas finally start behaving like a comet when it's at its closest point to Earth? Or will it continue defying expectations the way it has since July? But while we're waiting for December 19th to arrive, there are other questions circulating in the astronomy community that aren't being addressed openly, and I need to be clear here. What I'm about to tell you are reports circulating among amateur astronomers and some online astronomy forums, not officially confirmed facts. Treat them as rumours that deserve scrutiny, not established truth. That said, they're persistent enough that they warrant mention. First, there are reports, unconfirmed, that NASA's release of high-resolution images of 3i Atlas has been delayed beyond initially projected timelines. The claim is that imaging data from the Hubble Space Telescope and other facilities was expected to be made publicly available in late October or early November, but as of now, those images haven't appeared in public databases. Now, delays in data release aren't unusual. Image processing takes time, calibration and verification take time, peer review takes time. But the claim being made in some circles is that the delay is longer than standard processing would require, and that no official explanation has been provided. I don't have independent confirmation of this. I'm not a NASA insider. I can't verify the claim, but it's circulating, and if true, it raises the question, why would there be hesitancy around releasing images of an object that's supposedly just another comet? Second, there are reports, again unconfirmed, that congressional briefings have occurred regarding 3i Atlas. The claim is that members of congressional committees related to space and defense have been briefed behind closed doors about the object. The context of these briefings, the content and the conclusions are unknown. Some sources suggest the briefings were routine, simply informing lawmakers about an unusual astronomical event that's attracting public attention. Others suggest the briefings included discussion of contingency planning or observation prioritization. I don't know which, if any, of these claims are accurate, but if congressional briefings have occurred, that would be unusual for a standard cometary observation. It would suggest that someone in a position of authority believes 3i Atlas warrants attention beyond normal scientific curiosity. Now let me be absolutely clear. I'm not presenting these rumours as fact. I'm presenting them as claims circulating in communities of people who are paying close attention to this event. They could be entirely false. They could be misinterpretations of routine processes. They could be exaggerations based on incomplete information. But they exist, and they're part of the broader context in which the discovery of C/2025 V1 Borisov is happening. Because here's the thing, if these rumours have any basis in reality, then the appearance of V1 Borisov becomes even more significant. It's not just a scientific control experiment, it's a public data point. It's an object that amateur astronomers around the world can observe, image, and analyze independently without relying on official releases from institutions that may or may not be sharing everything they know. And that brings us to the observation window we're in right now. From late November 2025 through the end of January 2026, 3i Atlas will be visible to Northern Hemisphere observers with moderate-sized telescopes, 8-inch diameter or larger. It won't be visible to the naked eye. It's too faint for that. But for anyone with a decent telescope, dark skies, and the patience to locate it, it's within reach. And during that same window, C/2025 V1 Borisov is also observable, providing that direct comparison in real time. This is unprecedented. Never before have we had an interstellar visitor and a conventional comet observable simultaneously in the same region of sky, with comparable brightness levels during the same observational season. It's a natural experiment unfolding in real time. There's also the matter of the European Space Agency's opportunity. The ESA has a spacecraft, one of their deep space probes, whose trajectory will pass through a region near where 3i Atlas has already travelled. This isn't a close encounter. The spacecraft won't be flying by 3i Atlas itself, but it will pass through the comet's tail region, if a tail exists. If 3i Atlas has been shedding gas and dust that's being left behind along its trajectory, the spacecraft's instruments could potentially detect those particles. That data, if it's collected and released, could provide definitive evidence of outgassing, or confirm its absence. Again, this is an opportunity, not a guaranteed result. But it's on the table, and it's another data stream that could answer some of the outstanding questions. So here we are. 41 days until December 19th, weeks of optimal observation ahead, multiple independent observers around the world watching, a new comet providing a real-time baseline of normal behaviour, and an interstellar object that continues to defy easy categorization. The timeline has converged. The trajectory has positioned these objects in observable proximity, and the questions that need answering are about to reach their point of highest resolution. Which brings us to the question everyone's asking, even if they're not saying it out loud. What exactly are we watching for, and what would it take to prove that 3i Atlas is something more than just a comet? Let me tell you what observers should be monitoring during the remaining weeks of this observation window, because this is where theory meets measurement, where speculation meets data, and where we'll finally have enough information to draw conclusions that aren't based on incomplete datasets. December 19th is the focal point, the closest approach to Earth, but the observation window extends from now through the end of January 2026. That's roughly 10 weeks of prime viewing opportunity. And here's what we're looking for. First, tail development. If 3i Atlas is a comet, even an unusual one, and it's now past perihelion and moving away from the Sun, this would typically be the period when the tail is most visible. As a comet recedes from the Sun, the outgassing rate decreases, but the dust particles already released remain visible, trailing behind the nucleus. Many comets develop their most photogenic tails after perihelion, not before. So if 3i Atlas is going to show a tail, this is the window. Long exposure images from amateur astronomers with 8-inch or larger telescopes should be able to detect even a faint dust tail if one exists. If we reach the end of January and still no tail has appeared in hundreds of independent observations, that's significant. That tells us outgassing, if it's happening at all, is far below the threshold for visible tail formation. And that's not consistent with an object experiencing non-gravitational acceleration from cometary sublimation. Second, brightness stability and changes. V1. Borisov is fading predictably as it moves away from the Sun. That's what we expect. 3i Atlas should also be fading, following an inverse square law based on increasing distance from the Sun and increasing distance from Earth. If it continues showing unexpected brightening episodes, or if the brightness curve deviates significantly from gravitational predictions, that's another data point suggesting something non-cometary is at play. Conversely, if it suddenly starts behaving predictably, fading smoothly with no anomalies, that would suggest whatever was causing the earlier irregularities has ceased. Either outcome is informative. The key is to document it with precise photometry from multiple independent sources. Third, spectroscopic analysis. This is where professional observatories have an advantage, but some advanced amateur astronomers with spectrographs can contribute here too. Spectroscopy tells us what the object is made of by analysing the wavelengths of light it emits or reflects. If 3i Atlas has a coma, even a faint one, we should see emission lines from gases like hydroxyl, OH, cyanogen, CN, or carbon compounds. If those lines are absent, that's evidence of no active outgassing. If unusual emission lines appear, lines that don't correspond to known cometary gases, that would be extraordinary and would demand explanation. The colour changes reported in earlier observations suggest something is happening with the object's spectrum. Detailed spectroscopic data from December and January will clarify whether those colour shifts are real, and if so, what's causing them. Fourth, trajectory refinement. By the end of January, we'll have months of astrometric data, precise measurements of 3i Atlas's position in the sky over time. That data will allow orbital dynamicists to refine the trajectory with high precision, quantifying any non-gravitational acceleration and determining its direction and magnitude. If the acceleration is consistent with cometary outgassing, it should point away from the Sun and correlate with brightness changes. If it doesn't fit that pattern, if it points in an unexpected direction or varies in a way inconsistent with sublimation, then we're left with a puzzle that has no conventional solution. Now, let's talk about the natural explanations that are still on the table because it's important to be intellectually honest here. There are scenarios in which 3I Atlas could be a natural object and still exhibit unusual behavior. For example, it could be a comet with an extremely high concentration of carbon-rich materials and very low volatile content. Carbon doesn't sublimate significantly at the distances 3I Atlas has been at, so a carbon-dominated object might not produce a visible coma or tail. But if that's the case, it shouldn't be showing the brightness variations and non-gravitational acceleration we've observed. A mostly inert rock would behave like an asteroid, not like something actively changing. Another possibility is that 3I Atlas has a highly unusual rotation rate, or axis orientation, that's affecting how we see it. If it's tumbling chaotically, different surface areas with different albedos could come into view, causing brightness changes. But again, that doesn't explain the non-gravitational acceleration. Rotational effects don't produce thrust. Outgassing does. So we're back to the same contradiction. Activity without visible outgassing. Then there's the idea that 3I Atlas could be a comet that's already shed most of its volatile ices on previous passes through other star systems, and we're seeing the last remnants of sublimation from deep interior pockets of ice. That's plausible in theory, but it raises the question, why would such an object exhibit behavior only now, during its pass through our solar system? And why would the timing of its discovery coincide so precisely with the observation window when we're most focused on interstellar objects? On the other end of the spectrum, there's the hypothesis that refuses to go away, no matter how much mainstream scientists dismiss it, that 3I Atlas could be a technological artifact, not a spacecraft in the Hollywood sense, but a probe, a derelict, a sail, or some kind of object engineered rather than formed by natural processes. I'm not endorsing this hypothesis, I'm simply stating that it's part of the conversation and it's being discussed by credible scientists, not just fringe theorists. Dr. Avi Loeb has been vocal about the possibility that interstellar objects like Oumuamua and 3I Atlas could be artificial. His argument is straightforward. If we're going to take the search for extraterrestrial intelligence seriously, we have to be willing to consider that evidence of technology might arrive in the form of objects passing through our solar system, not just radio signals from distant stars. The WOW signal correlation, the fact that 3I Atlas's trajectory passes within 9 degrees of the WOW signal origin point, is circumstantial. It could be pure coincidence, but coincidences accumulate. The same astronomer discovering 2I/Borisov and V1 Borisov during the 3I Atlas observation window, the timing of V1's discovery just days after 3I's perihelion. The stark behavioral contrast between the two objects, the lack of a tail despite non-gravitational acceleration, the colour changes, the brightness anomalies. At some point, the number of coincidences required to maintain a purely natural explanation starts to strain credibility, and you have to ask, what would it actually take to convince us that we're looking at something artificial? Here's the criteria I'd propose. If 3I Atlas exhibits a trajectory correction that can't be explained by cometary outgassing or gravitational perturbations, that's strong evidence. If spectroscopy reveals materials or structures inconsistent with natural formation, that's strong evidence. If the object shows periodic brightness variations consistent with artificial geometry, like a rotating solar sail or a tumbling piece of debris, that's strong evidence. If radio or infrared emissions are detected that can't be attributed to thermal radiation, that's strong evidence. None of those things have been confirmed yet, but we're in the observation window where they could be, and this is why the appearance of C/2025 V1 Borisov matters so much. It's the baseline, it's the control, it's the proof that we know what normal looks like, so when we see something abnormal we can recognize it. Gennady Borisov, the man who found the first interstellar comet, has now given us the tool to understand the second interstellar visitor. V1 Borisov behaves like a comet. 3I Atlas does not. That's not speculation. That's observable fact. The question now is, what do we do with that fact? For anyone with access to a telescope, I encourage you to observe both objects during this window. Document what you see. Share your images on astronomy forums, in social media groups, in academic platforms like the Minor Planet Center or the American Association of Variable Star Observers. This is one of those rare moments in history where amateur astronomers can contribute directly to a question of profound significance. You don't need a PhD, you don't need a billion-dollar instrument, you just need clear skies, a decent telescope, and the willingness to look. Because here's the truth. Whether 3I Atlas turns out to be a strange comet, a technological artifact, or something we don't have a category for yet. The fact that we're asking these questions is itself significant. The fact that we have the tools, the data, and the comparative baseline to investigate rigorously is progress. The fact that an amateur astronomer in Crimea, working alone with a homemade telescope, can contribute discoveries that change the entire framing of the investigation is proof that science isn't just what institutions do. It's what curious people do when they refuse to accept easy answers. We'll know more in the coming weeks. We'll have better data by the end of January, and I'll be here covering the December 19th close approach and whatever comes after. But until then, keep watching, keep questioning, and keep in mind that sometimes the most important discoveries aren't the ones that confirm what we already believe. They're the ones that force us to reconsider everything we thought we knew. C/2025 V1 Borisov is normal. That's the discovery. And because it's normal, we now know for certain that 3I Atlas is not. What comes next is up to what the data reveals. The story isn't over, it's just beginning.